Okay, this is a video on how to do a time series analysis. The time is 9:28 on this clock, and hopefully this video will last around 8, 9, 10 minutes. We have some data here from May 98 through to March 2002, just representing some occupancy rates of hotels somewhere around New Zealand. The year has been split up into 6 blocks of 2 months, so that's going to make it worthwhile doing moving means of order 6. So our first column is going to be our uncentered moving means, and because we're doing order 6, we'll place the first one in the fourth piece of data down. Equals average. Always start a formula with equals. Scroll and hold the first 6. No need for the end of bracket there. Press enter. And now, as we know, we can scroll right down to the third from last. If we started the fourth from the top, we end with the third from last. And just to make sure that is the correct moving mean, if we just click in that cell and check that it's the average of C20 to C25, which is the last 6 data items. So that's all good. Now, as we know, we've got an even number of data points, so we've got to do now the centered moving means. Okay, now the first centered moving mean will be placed next to the fourth piece of original data, so it will still be in line here, and it's basically the average of these two moving means. So again, equals average. There we go. Okay, again, we can drag down the formula down to the second to last non-centered moving mean, and just check that the last centered moving mean there is the average of these two here, D22 to D23. Yep, that's good, that's what we want. So we've got our time period, raw data, centered moving means. Now let's copy and paste all of those together. Time period copied, we'll just place it here. Moving means. Now because these are raw data, sorry, not the uncentered moving means, so we can copy and paste that. It's really important now when you copy and paste the centered moving means that you go right click, paste special, values only. That's because these values are calculated on a formula, and if we didn't do paste special values only, these values would change. I don't like the fact there's so many decimal places here, so I'm just going to ask Excel to do it to 1 decimal place. Format cells, number, 1 decimal place is fine. Okay, let me just format the text box there so it wraps it around. General alignment, wrap, that just tidies things up. Now we can do our graph, so we highlight everything, insert scatter, the one with the lines joined, and we can see we've done a really good job of smoothing out the data. Those moving means really look as though they've done a tremendous job smoothing out. Okay, let me just reduce the size of that a wee bit, place that over here for now. I may move it again later. Okay, let's just place our trend line on now. We must right click on the centered moving means, add trend line, display equation, display R squared, default as linear. That's all good. Place that up there. Just make the text there a wee bit bigger. Okay, so we can see straight away that's a pretty good model. That's a pretty good model. Okay. So next thing now is to work out the individual seasonal effects. So we can put that in here. I'll just abbreviate it to ISE. And remember, the individual seasonal effects are the raw data minus the moving mean, the centered moving means. The first one we can work out is here. So equals this cell minus this cell. So that tells us that the time period 4, which was October to November, was not that good. Scroll right down. Let's have a look for a positive. So we can see time period 5, which is a December and January, so over the summer holidays, is a very positive individual seasonal effect. Okay, now we need to work out the average seasonal effects, which is the average of all the individual seasonal effects. Now this is a little bit tricky, a little bit fiddly, but again equals average, and this is the April and May 2-month block. So the raw data starts, let me just move this out of the way so I can see the original data. Okay, equals average. Now we're working out the average of all the May individual seasonal effects, so that's going to start there, comma, space, and now to the next May, which is there, and just one more May, which is there. No need for the close brackets, hit enter. Now for the average seasonal effect for the June and July. So the first one there is that one there, comma, now the next June and July, that one there, and comma, last one is there, close brackets. It's not surprising that the average seasonal effect for May, June, July is negative. Not many people staying in hotels there. Now for the August, September, which is there, there, and the last one there. And now for the October, November, first of which is up here, second is there, and there's the 3 there, so small. So everything's got an average seasonal effect which is negative at the minute, but this should swap around now. And a huge positive average seasonal effect for December and January. What about February and March? Equals average. Just made a wee bit of an error there, so I need to go back and change that and make sure I put the comma in. That was my stuff up there. Okay, so of the 6 seasons, 4 have a negative average seasonal effect and 2 have a positive. One of them has a particularly large positive seasonal effect. Okay, well that allows us now to work out seasonally adjusted values. Remember, seasonally adjusted values is the raw data minus the average seasonal effect. So for a May, April-May period, that's going to equal the raw data minus that, equals 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 the raw data minus that. Okay, and this is the first one of any use. This is the first line where we can compare the seasonally adjusted value to the centered moving means. And we can have another column here which says above, below, expectation. Just make that look a wee bit neater. So this one here, the seasonally adjusted value is below the centered moving mean. So we know October and November was a negative period, not too many people staying in hotels, but this was below expectation. So yes, we know October and November are bad, but this was even worse than expected, even with the seasonal adjustment taken into account. And we can carry that down. Now, to make a prediction, we substitute our time period value into the equation. We get a value, and then we must add the average seasonal effect. Now, I'm just going to go for July 2005, which is when I arrived in New Zealand. Let's work out what time period July 2005 is. Let's highlight a few, carry on. I actually need to use this one here because this has the actual dates in. So let's just extend the time periods, Let's just go down to about 50. If we need to go on, we can. Let's highlight the last few here and carry on the pattern. Down to 50. And July 2005 is time period 44. So that means we're going to substitute 44 into this equation. So that's going to equals, let's do equals 24.422 times is the star button above 8 times time period 44 plus 1859.8. Now we need to add the average seasonal effect for July. So we actually need to take away 515. So the prediction for July 2005 using the trend line is 2,419. Okay, the only way we can check that out is to get the real data, but we can be reasonably confident about that. Look how good the trend line is to the smoothed centered moving means. It's pretty smack on the nail. 98, nearly 99% squared. Only 1% of the variation cannot be taken into account by the model. There's a wee bit of a dip there, but pretty much smack on. The data can be modeled very nicely by a linear line. Okay, well that's basically up to and including merit on this topic. Good luck, and if you need any more questions, just you know the guy to ask.